Welcome to this tutorial. The last tutorial we did, we talked about I talked about Russell model, and I mentioned some of the factors uh, involved in Russell model, and I said that Russell model is used for determining annual soil erosion loss. Now, the first tutorial I have I have done analysis on how to perform or do your or create your rainfall erosivity factor map. So in this tutorial, I'm going to show you how to create a soil erodibility factor map. Now, we are going to do all the necessary things involved in the Russell model, and at the end of the day we are going to combine everything together. We are still going to do the length of slope, that is the topographic factor. We are still going to do the cover crop management factor. Then finally we are going to do the annual soil loss. Annual soil loss has to do with the combination of all the other factors, that is the rainfall erosivity factor, P factor, the soil erodibility factor, the K factor, the cover crop or management factor or land cover factor, the length of slope. Now today we are going to look at how you can create your soil erodibility factor map. First, for you to create a soil erodibility factor map, you are going to need the soil map of the world, which you can download from FAQ. You can actually download the soil map from FAQ. That is FAQ.org. So now, once you download your soil map, the next thing to do is now to start your analysis and how you can actually the steps you need to take before you can create your soil erodibility factor map. Now the first thing we are going to do is we are going to bring in the map of the world, the soil map of the world. We are going to bring in the soil map of the world, which is very important. Okay, now this is the soil map of the world. I'm going to bring it in DSMW. So now I brought it in, but it's asking me to repair the source, so I'm going to right click on it to repair the source. Then you go to data, then repair data source. So I'm going to bring this in. Now this is it. So now I'm going to bring this up. I'm going to bring it up. You can see this is for Oyo State. So I'm going to clip out Oyo State. So I'm going to clip out this part. So I'm going to clip out the section for Oyo State because that is what I need. So I'm going to clip out the section for the state for Ibadan. Yeah, this is Ibadan. So I'm going to clip out the soil map with the boundary area of Ibadan. So now to do that, I will go to my Arc toolbox, then go to my analysis, then go to my extract, then clip. So here I'm going to bring in the soil map. So and the clip extent will be Ibadan. So the clip extent now will be Ibadan. So let me just create a folder. Let me just create a folder here, call it Rusu. So I am going to click on it and save it. Ibadan soil. Then click OK. So it's done. So I'm going to uncheck this. You can see this is just what I need. So now what I'm going to do here is I'm going to right click on this, go to my properties, then go to categories. So here I'm going to select dome soil here, and I'm going to add value, you can see. So I'm going to click OK. So these are the two soils here. You can see we have I and LF. So for us to know the names of this soil type, I'm going to go to the soil map of the world, extend it. So I'm going to look for I. You can see this is little soils. Then LF here is what? Ferric Nubi soils. So now this is what I will do. The next thing is that I am going to go to the folder where the soil map is, because there are some informations there that we need to use in order to create this soil erodibility factor. So I'll go to the soil map of the world, then you can see, open it. Now you can see we have soil data here. We can see we have soil information. So we open this SU, that is soil information. So you can see. So now you can see these are the informations now. So I'm going to look, bring out high, that is the Luffy soils and the little soils. So I'm going to bring out the first one, which is the I, that is the little soils, capital L rather, little soils. You can see this is it. So now what I need there is this. I need just four things. I will need the sand topsoil, the silt topsoil, the clay topsoil, then the organic carbon topsoil. Those are the things I need. So now this is I. Now this is the first one, 58, 16.2, 24.9, then this. So this is the first one. I'll copy. So the first one is, that is the sand soil. So I'm going to copy this and open another page. So you can see this is a sand topsoil. So I am going to copy this, then copy it here. Then I am going to copy this. That is the silt topsoil. I'm going to copy it here. Then I'm going to click on this too. Then that is the clay topsoil. Then the last one, that is the organic carbon topsoil. So here, that is for I. That is the little soils. So now that is I. Then the second one is the LF, which is the ferric Luvi soils. Now I'm going to look for the sand topsoil. So LF, this is it here, 74.5. And sand topsoil. Then the next one is this. This is the next one. 9.6. That is the silt topsoil. Then the clay topsoil, 15.9. Then the organic carbon. The organic carbon is this. You can see. That is the organic carbon. Yeah, 0.39. That is 0.39. So now this is what I need. So I'm going to save it. Then continue. So what I'm going to do here is I'm going to go to File, Save As. Then select this. Then I will say Ibadan. Then save. So that is sheet 2. Can you see? That is sheet 2. So now you can see that I've saved it as, Ibadan. So now I'm going to go to ArcGIS interface. So you can see this is the table. You can see this is the table. So I am going to match this. I'm going to try to match this together, so that it will only remain this, that is the little soils and the ferric loamy soils. So I am going to just go to my select by attributes. Then I will say dome soil equals to LF. Then apply. Then you can see will just go to match. You can see it's now 1. So now what the next thing I will do is, let me save this. I'll save this. So I am going to create another field. So I'm going to create another field and call it the okay, this is how we are going to do it. I'm going to right click on this, go to join and relate. So here I'm going to bring in the Ibadan. So that is sheet 2. So here I'm going to select the dome soil. You can see dome soil, and then I'm going to validate. So you can see it's already joined. So but let's see in case it doesn't join, there is another way we can do it. You can see it's already joined. Now you can see the silt, the clay, the organic topsoil. So what you are going to do in this case is that we can now export this so that it will become a normal shape file. So we can export this. So we just say soil, then save. So now we can check this. So we can go to attribute table and check again. Can you see the sand, silt, clay, everything is there. So this is it. Then here we are going to create another field here. So we have some field we are going to create here. We have calculating K factor. We have the F organic matter, that is FOS, FOC. We have the F sand, we have the F clay, we have the LC. Then after we calculate all this, we will now determine the K factor. This is the formula for the K factor, and this is the formula for each of the factors. So we are going to create a field for F organic matter. So here, we're going to say F underscore organic. So we are going to select double, then you click OK. So the next, we are going to create another field. So here you can see we are going to create F sand, F underscore sand. So we are going to select double. Then here we are going to select add field. Then we are going to create F underscore silt, F silt. Then we are going to select double. So the next one, we are going to create F clay. We are going to create F clay, F clay, double, then click OK. Now they are formulas, but I decided to break it down to the normal formula that ArcGIS will understand. So they are formulas, but I decided to break it down so that once you follow this particular step, you input it inside ArcGIS, it is going to, the analysis will work once. If you look at the normal formula, you may get confused, but that is why I decided to break it down to this, which is going to help you. So now I am going to, I've already created it, you can see. So now I'm going to calculate the F organic matter. So I'm going to right click on this, go to field calculator. You can see, go to field calculator, and this is it. You can see F organic matter. So here I'm just going to copy this F organic matter. I'm just going to copy this, copy, then come to ArcGIS, to this field calculator, then paste. You can see. So the only thing I need to change here is this. You can see organic carbon. So I'm going to impute the real one there. So I'm going to impute that is carbon. This is organic carbon. I impute. Then the next one, you can see you also put organic carbon here. So I'm going to put organic carbon here as well. I'm going to put organic carbon here as well. Then here you can see I put a space in between this. So now I'm going to delete this as well, and I'm going to put organic carbon. You can see topsoil there. So you can see it's done already. You can see others are there already, so it's just for me to impute the organic carbon. So I will just click OK. Can you see the F organic matter has been calculated? So I break the formula down in such a way that once you input it into ArcGIS, it will respond once. You understand? Because if you see the original formula, for you to be able to run it, to look it and be running it will give you issues, might give you problem. That is why I decided to break it down like this, so you can just check it and see the things I did and just follow. Now the next thing, I will calculate the F sand. Right click, then field calculator. Then I'm going to copy the formula for the F sand. You can see I've already done everything here. So now I'm just going to input. So the only thing I need to change here is this sand. So I'm going to change it with the one here, sand. Then here I am going to change the silt, and I'm going to change it with the one here, silt. So that is all. Then I click OK. You can see the F sand is already calculated. So you can see the F sand, the F organic matter is already calculated. The next one is the F silt. I will right click on it as well. Go to my field calculator. So I'm going to copy and paste the formula there. This is F sheet. I'm going to just copy and paste the formula there. So here I'm just going to copy and paste the formula. So copy and paste. So here sand, I'm going to remove this and now put the sand which is here there. You can see sand. Then here I'm going to remove and also put this here sand. So here I'm going to put sand there. So that is all for that. Then I will run. You can see it has been calculated. So now this is the F clay field calculator. Then I'm going to just copy the formula F clay. So I'm going to calculate the formula for F clay, then paste it here. So silt here, I'm going to remove it, then now use the silt here. Then here I'm going to use the clay. Then here I will remove this and use my silt here. Then calculate. Now you can see now this is the 4 factors, the F clay, the F sheet and all that. So here you can see now, looking at K factor, K factor is soil erodibility factor, which represents both susceptibility of soil to erosion and the rate of runoff. Now you can see that soils high in clay have low K values. That is about 0.05 to 0.15. Look at this, we have 0.7, 0.7. So these ones are low in, they are high in clay. So soils that are high in clay have low K values. So which means that this has a higher K values, which means that the soils are low in clay. So soils that are low in clay have high K values. Now, coarse texture soils such as sandy have low K values about 0.05 to 0.2. So that is, sandy soils have low K values. So sandy soils have low K values. You can see this is this. You can see 0.2, 0.2. So it is always between 0.05 to 0.2, which means that the soil the soil have low K values. That is low soil erodibility factor. That is, it has low K values. Now you can see this medium texture soil such as silt have moderate K value about 0.25 to 0.4. That is silt, that is moderate K value. Silt, moderate K value. You can see this have a higher K value. Now the next thing I am going to do is to go to this place. Then I will create another field, and that field will now be for the K factor. K factor. That will now be for the K factor. You can see. So now for the K factor, all I need is this. This is the formula. I will copy it. So here I will right click on K factor, then go to field calculator. Then here I will paste the formula. But here I'm going to delete this. So that will be F sand multiplied by F clay, then multiply by F organic matter, F organic carbon, then F silt, then multiply by 0.1317. then so you run. You can see this is the K factor for the soils. You can see this is the K factor. This is the K factor for the soil. So this is the normal K factor for the soil. So here you can easily go to properties, then go to quantities, then go to graduated symbols. You can see. Now go to K factor, graduated colors. Now go to K factors. Then you can see. Then you run. So you can see this. So once you do, you can see your K factor. Now the best thing, what we are going to do here is that you convert this to raster. So we convert this to raster. So we go to conversion to, then from polygon to raster. So we are going to input the future, which is soil. So here we are going to select the K factor. So you can see. So here we have the K factor map. So here we have the K factor map. So here we have the K factor map. So we run. So you can see here is the K factor map. So here we have the highest value and the lowest value. You can see now this is the highest K value and this is the lowest K value. So here we have the raster. It has been converted to raster. So now this is our K factor map. Here is the K factor map. You can see here is the K factor map. So here is the K factor map. Let's change the color. Yeah. So let's change the color here. So this is the K factor map. Here it is. So this is the K factor map. This is the highest and this is the lowest. So here is the K factor map. And the K factor is between 0.01, which is the highest, 19 to the lowest, which is 0.017. So this is the K factor map. And in our next tutorial, we are going to look at how you can create your length of slope. So once we create all those factors, we are now going to match them together. We are now going to, we are going to use a formula to match them together in order to create the annual soil erosion map. So please subscribe to my YouTube channel, and if you have any question, you can drop your question at the comment section. Thank you very much. Have a great day.